Okay, I'm going to look at some area exam questions, and they're a bit challenging just because they're different to some of the previous ones that we've seen here. So first of all, it says the curve C shown in figure 1 has the polar equation r equals 4 plus cos 2 theta. So we're talking about this part that we've got here, and it's just between 0 and pi over 2, which we can see. At the point A on C, the value of r is 9 over 2. So we know something about this, which I'm immediately going to put onto the diagram, that it's 9 over 2 for that length of the line. The point N lies on the initial line, and AN is perpendicular to the initial line, so I know this is the right angle. The finite region R, shaded in figure 1, is bounded by the curve C, the initial line, and the line AN. Find the exact area of the shaded region R, giving your answer in the form p pi plus q root 3, where p and q are rational numbers to be found. So if we think about what the strategy is going to be here, it looks like we're going to find out the area of this whole, well, not really a sector because it's not a circle, but we're going to find the area of this whole shape that we've got here. And then what we're going to do is we're going to subtract the area of the triangle. That should give us the area of R that we have here, okay? So I think what we need to do is we should begin by trying to find out what this angle over here is. So I think we're going to have to use this equation to find out what theta is. And we know that r is 9 over 2 at that point. So for part A of the question, or not part A of the question, I'm actually going to find out the angle at the coordinate A. Now we know that r is equal to 9 over 2. So I can say that 9 over 2 equals 4 plus cos 2 theta. So 9 over 2 subtract 4 is a half, so a half is equal to cos 2 theta. And we know then when you do the inverse cos of a half, we get that 2 theta is going to be pi over 3. And so theta is going to be equal to pi over 6. So I can come back to here and I can say this angle is pi over 6. So A has coordinates 9 over 2. Pi over 6. So to try and find out the area of this whole, I'm calling it a sector, it's not really a sector, but this kind of shape that we've got here, we're going to be doing this by integrating between 0 and pi over 6. So we are going to find that kind of shape, this area is going to be equal to a half r squared between 0 and pi over 6. And r is 4 plus cos 2 theta. So that's going to be 4 plus cos 2 theta all squared with respect to theta. Expand the brackets. So it's going to be 16 plus 8 cos 2 theta plus cos squared 2 theta with respect to theta. So there's going to be your 16, your 8 cos 2 theta, and cos squared 2 theta is going to be a half plus a half cos 4 theta. Don't forget to double the angle that we've got there. Okay, I'm just going to do that line one more time, and this time I'm going to still leave the half outside the front. I don't think I need to do much more to this. I'm going to do the 16 plus the half, very lazy, just because I want it as a fraction. I think it's going to be 33 over 2. So we get 33 over 2 plus 8 cos 2 theta plus a half cos 4 theta. So we're going to go in with the integration. So I'm going to put my half. I'm going to have my 33 over 2 theta. I know it's going to be a sine 2 theta, and it's going to be an 8 over 2, which is 4. I know it's going to be a sine 4 theta, and I'm going to divide by 4, so I get an 8 sine 4 theta, and that's between 0 and pi over 6. So I might just do some little jots down at the side that if theta is pi over 6, when I sub in 2 theta, it's going to be pi over 3. And when I sub in 4 theta, it's going to be 2 pi over 3. That might help me with my substitution. So we're going to have a half. Let's sub in the pi over 6. So we're going to have 33 over 2 multiplied by pi over 6. Then we're going to have plus 4 sine of pi over 3. Well, I'm going to go straight in with that actually. So sine of pi over 3, I should know that one actually. Sine of pi over 3, it's a bit early for me this morning. It's root 3 over 2. So that's 4 times root 3 over 2. Plus an 8 times the sine of 2 pi over 3, which is root 3 over 2. And when I subtract, when I put 0 in here, it's all going to go. When I put 0 in here, it's going to go. And when I put 0 in here, it's all going to go. So that's actually the whole thing that we've got. So it's going to be a half multiplied by 33 pi over 12 plus 2 root 3 plus root 3 over 16. So I'm going to do that 2 root 3. I'm not going to put the root 3 in, plus 1 over 16 to see how many root 3s. So I've got 33 over 16. So it's 33 pi over 12 plus 33 over 16 root 3. And I'm going to do that multiplied by a half. So I'm going to get 33 over 24 pi plus 33 over 32 root 3. So all I need to do now is find the area of the triangle. So this next part of the strategy is going to be finding the area of this triangle that we've got here. Okay, well, I think we can probably find out the base and height of that triangle. So I'm going to sketch this out again for the triangle. Here's the triangle. I know this is 9 over 2. I know that this is pi over 6. And so this is clearly going to be the y-coordinate, which will be r sine pi over 6. And this will be r cos pi over 6, the x-coordinate. And so the area of the triangle is going to be equal to a half times the base, which is 9 over 2 cos pi over 6, times by the height, which is 9 over 2 sine of pi over 6. So that's a half times 9 over 2 times root 3 over 2 times 9 over 2 times a half. So in the numerator, we've got 81 root 3. And in the denominator, we've got 2 times 2 times 2 times 2 times 2, which is 32. So the area of R is going to be equal to, our strategy is this one at the top, subtract this one that we've got here. So it's going to be 33 over 24 pi plus 33 over 32 root 3 minus 81 over 32 root 3. So I can just deal with the root 3 bits. So I'm going to do 33 over 32 minus 81 over 32, and that's minus 3 over 2. So our area should be 33 over 24 pi minus 3 over 2 root 3. Let's see if we got this right. So the strategy here, just talking through what we've got. Oh, what did I do wrong here? 33 over 24. I didn't simplify that. That's really silly of me. 33 over 24 is 11 over 8. Let's just quickly fix that here and here. I wonder why I didn't simplify that. Didn't spot that it could all be simplified to 11 over 8. I don't know if I'd lose a mark for that. I'd hope not, unless it said simplified fraction. No, it just said rational numbers. I probably wouldn't lose the mark. So the strategy you can see, finding out the angle, integrating, using the rearranged double angle formula, coming out with all of these different bits of the limits, area of the triangle, subtracting, and then the 11 over 8 and the minus 3 over 2 root 3. Okay, 9 marks, pretty good question. Here is where things get quite further mathsy. So we actually dealt with this shape before, so I'm not going to spend too long looking on this. If you want to check it out, it's in an earlier video that says for strategies for harder areas, and it says spirals in brackets. This is the kind of spirally shape here. So I'm not going to spend too long on the strategy, just going to see if we can answer this question. So it says figure 1 shows a sketch for the design of a logo. The logo is defined by the polar curve with this equation, and it's telling us it's going between 0 and 6 pi. The inner closed section and outer closed section of the curve as shown shaded in figure 1 are to be coloured the same colour. The remaining section is to be left clear. Use algebraic integration to find the area of the coloured sections of the logo. So I'm going to go through this kind of quickly, but we know because it's sine, this bit here is where it's starting with angle 0. When it gets to this bit, it's then going to have angle pi. It's coming around like this when it gets to 2 pi. Then it goes on the outside, because it can't go on the inside, because then you'd never get to the outside. Then when it comes back over here, it's going to be, this is pi referring to this bit. This point over here is 3 pi, And when we keep going around the outside, we then get back here. So the second time it's here is going to be 4 pi. And then as a reminder, it gets to this bit at 5 pi, and then it comes back to the origin at 6 pi. So the strategy for this was to do the big circle, big semicircle of it, or that semicircle shape. It may not be exactly a semicircle. And then to remove this part. But then because you remove this part, you need to add this part back in. So the strategy that we're going to do, and I'm just going to jot it down, and I'm going to be a bit lazy with these bits that I have. I'm not going to do this in a lot of detail. So we're going to be the big part. Now it goes 0, pi, 2 pi, and 3 pi. So we're going to first of all do the 0, the 2 pi, and 3 pi. That's the bit we want to have to begin with. We're then going to remove this larger part. So that's 3 pi, and it comes around here to 4 pi, and then this inside bit is going to go between 4 pi and 5 pi. So we're going to remove between 4 pi and 5 pi. But then the last part that I said we need to add back in was this green part, which was the original bit between 0 and pi. So we're going to add back in it between 0 and pi. Okay, that is going to be our strategy for this question. So we should now just be able to go straight in with working this out. So I think that our area is going to be equal to, and remember we're going to be doubling this whole thing because it's going to be a half and we're just wanting to do doubling of the whole thing. It is going to be the integral of r squared minus this plus this, and the limits we said were between 2 pi and 3 pi, between 4 pi and 5 pi, and between 0 and pi. Okay, so I'm actually just going to work out what the integral of r squared is with respect to theta without the limits to begin with. And r squared is just sine of theta over 6 squared. So sine squared theta over 6 with respect to theta. It's going to save me having to write it out 3 times because all 3 things here are the same as each other. So sine squared I'm going to replace with a half minus a half cos of 2 theta. So I'm going to do 2 lots of theta over 6, which is going to be theta over 3. And that's going to be with respect to theta. So when I integrate this, I would have a half theta. Now it's going to be sine of theta over 3. And because it's over 3, when I divide by over 3, I'm going to be timesing it by 3. So I'm going to have minus 3 over 2 sine theta over 3 plus c. And you can just check if this bit here differentiates right. You'd have your minus 3 over 2, you'd multiply it by the third, and it would go to cos of theta over 3, and you would get the minus a half cos theta over 3. So I'm going to do these little bits individually, okay? I'm going to do this first bit here in red. So I'm integrating between 2 pi and 3 pi of r squared with respect to theta. This is me always making this mistake, and I get very lazy and forget to put in the d thetas. Don't do what I do. So I'm going to actually just go straight in with the limits. It's going to be a half theta minus 3 over 2 sine of theta over 3, and that's going to be between 2 pi and 3 pi. Obviously, you don't need to use c anymore. So I'm going to have, when I sub in the 3 pi, I'm going to have a half of 3 pi, which is 3 over 2 pi, minus 3 over 2 multiplied by the sine of 3 pi over 3, so the sine of pi. Now the sine of pi is just going to be 0. Yeah, sine of pi is just going to be 0. So this thing isn't actually going to be needed. And then I'm going to be subtracting from this a half of 2 pi, which is just pi. And then I'm going to do minus 3 over 2 sine of 2 pi over 3. That's putting 2 pi inside the argument then. So we get 3 over 2 pi minus pi plus 3 over 2 times by sine of 2 pi over 3. So sine of 2 pi over 3 is root 3 over 2. So that becomes 3 pi over 2 minus pi is a half pi. And then we get 3 root 3 over 4. Okay, let's do the next bit in a different color. Let's do purple for this bit, which we're going to be subtracting. So we're going to do the same thing, but between 4 pi and 5 pi. So we're going to go between 4 pi and 5 pi of r squared. Oops. So subbing in 5 pi, I'm going to have 5 over 2 pi minus 3 over 2 times by the sine of 5 pi over 3. So I'm going to do the sine of 5 pi over 3, which is minus root 3 over 2. Then I'm going to be subtracting from this, putting in 4 pi. Well, a half of 4 pi is 2 pi. And then I'm going to do minus 3 over 2 multiplied by the sine of 4 pi over 3, which is minus root 3 over 2. So we have 5 over 2 pi plus 3 root 3 over 4 minus 2 pi, and then this is a negative times a negative times a negative, so it stays as a negative, minus 3 root 3 over 4. And so what you'll spot happening here is that these are going to cancel, and so this simplifies to just 5 over 2 pi minus 2 pi, which is just a half pi. The last section now, I'll do this in this black color. I'm just going to be doing the same thing, but between 0 and pi. Quite a lot of work here. So between 0 and pi, when I put pi in, I'm going to have a half pi minus 3 over 2 sine of pi over 3. Well, that's the sine of 60, and the sine of 60 is root 3 over 2. And then when I put 0 into the other bits, it's just going to be the same. It's just going to be 0 for both of them. So I'm not going to do 0 plus 0. It's just silly to do that. So I get a half pi minus 3 root 3 over 4. So it was, this one is positive and being added, this one's being subtracted, and this one is being added. So the area is going to be equal to the top one, a half pi plus 3 root 3 over 4. We're then going to subtract a half pi from the second one, and then for the last one we're going to add on a half pi, subtract 3 root 3 over 4. So it looks like we've got some things cancelling. The half pi here and the half pi here, the root 3 here and the root 3 here. So it looks like, and I'm going to check the answer before I go on to the second part, that this is just going to be equal to a half pi. Let's just see if we've got that bit right. Yep. So we have got this first bit right of it just being a half pi. It's pretty amazing. This shape has an area of a half pi. Pretty cool. Okay, so it says a copy of this logo is to be painted on a white wall of a building such that the total width of the logo is going to be 12 meters. So they want the width of the logo to be 12 meters. Tins of coloured paint with an advertised minimum coverage of 30 meters squared are to be used to paint the coloured sections of the logo onto the wall. Given that two cones of paint will be needed, so that's going to be important, we need the area twice. Find the minimum number of tins of this paint that should be bought to ensure the coloured sections of the logo can be painted onto the wall. Okay, so I think we need to try and think about how it is scaled up. So we have here, this is for part B of the question, we have got our spirally thing. Oh my gosh, am I going to try and draw this? I mean, that's a terrible drawing, but we have got that the area of this is equal to a half pi, and we need to figure out what this one's width is, okay? So I'm going to go back to the nicely drawn one. We know that the width is going to be subbing in 2 pi and 3 pi to find out the values of r, okay? So when I sub in to my equation, so this bit over here is 2 pi, this bit over here is the angle of 3 pi. When theta equals 2 pi, r equals the sine of 2 pi over 6, which is the sine of pi over 3, which is root 3 over 2. And when theta is equal to 3 pi, r is going to be equal to the sine of 3 pi over 6, which is the sine of pi over 2, so sine of 90, which is 1. Okay, so what we're going to talk about is that the width then, if we're saying it's r over here is root 3 over 2 and r over here, or where it's 3 pi, is 1, the width is going to be equal to 1 plus root 3 over 2. So we need to compare this logo to the other logo by thinking about their scale factor. So the linear scale factor it's gone from 1 plus 3 over root 2 to 12. So the linear scale factor is going to be the larger one divided by the smaller one, like this. That will tell you how much it has scaled up in like a left and right direction. And if I call that k, the area scale factor is just going to be equal to k squared. In other words, it's going to be 12 plus 1 over root 3 over 2 all squared. So to find the area of the logo is going to be the original area, which is a half pi, and you're going to multiply it by k squared, which is 12 plus root 3 over 2 all squared. So let's just figure out what this is going to be. We're going to have a half pi multiplied by 12 over 1 plus root 3 over 2 all squared. And so we get that it's 64.96 meters squared, but we want 2 coats. So we need that multiplied by 2. So we need 129.9 meters squared of paint. I'm going to just get rid of, don't really need that equal sign there, is needed. So we do 129.9 divided by 30 to find out how many tins we need. So we get 4.33 tins. So should buy 5 tins so that you have enough. So should buy 5 tins to have enough paint. Okay, let's see how that second part went. So I'm interested in seeing this number of the 129.9, then that should be correct if we've got this. So the strategy was to do the area of the curve, multiplied by this is k squared here, 12 divided by the width of the curve squared. We've got the width of the curve squared was this, and we've got 129.9, so 5 tins of paint will be needed. Okay, great. I hope that question went well. It's a pretty tricky question, particularly this weird part in part B, especially the fact that they asked for 2 coats. But I'll leave it up here for you guys to just remind yourselves of that method.